All right, good morning, everybody. Today I'm going to go over the answers to the review for Unit 8, Conservation and Thermal Energy. So there were four typos in this review, so I'm going to go through those as well. Before we start going over the answers, does anyone have any questions? All right, let's go through them. Number 1 says determine the kinetic energy of a 5 kilogram object, so that's our mass, that has a velocity of 2 meters per second, so that's our velocity. And we want to know the kinetic energy. For this one, kinetic energy is equal to 1/2 mv squared. That's one of the formulas you need for the test. So we're looking for kinetic energy. 1/2 is the same as 0.5, mass is 5, and your velocity is 2. And don't forget to square that velocity, only that velocity. So when you plug in all that to your calculator, you should get 10 joules, which is your answer. Number 2. What is the mass? So we're looking for mass of an object that has 300 joules of kinetic energy, so that's our kinetic energy, and a velocity of 1.5 meters per second, so that's velocity. So we're going to use that same formula, kinetic energy equals 1/2 mv squared. We know our kinetic energy is 300. 1/2 is the same as 0.5. We're looking for our mass, and our velocity is 1.5 squared. So yes, you can combine your 0.5 and your 1.5 squared. You can do that because of the rules of algebra. They're all being multiplied, so you can just multiply those two together. So you're going to get 300 equals 1.125 m. Then you're just going to divide both sides by 1.125, and your mass is going to be 266.67 kilograms, which is your answer right there. So yes, good job. Any questions on these two? All right, let's go on to the next. Number 3, determine the velocity. So we're looking for velocity of a 150 kilogram diver. 150 kilograms is our mass. Right before they enter the water, if their kinetic energy is 150 joules. So that's our kinetic energy. We're going to use that same formula. Kinetic energy equals 1/2 mv squared. Our kinetic energy is 1500. 1500. 1500. 1/2 is the same as 0.5. Our mass is 150, and we're looking for that v squared. So 1500 is equal to 0.5 times 150, that's 75 v squared. Divide both sides by 75, you get 20 equals v squared, and then you got to square root both sides, so your velocity comes out to 4.47 meters per second, which rounds to 4.5. Any questions? Don't forget to square root your answers whenever you're looking for velocity. All right, number 4, what is the potential energy? So now we're looking for potential energy of a 50 kilogram object, that's our mass, that is suspended 100 meters above the ground. So 100 meters, that's our height. Our formula for potential energy is mass times gravity times height. Sorry, that's gravitational potential energy. Same thing. They're all the same. We didn't use elastic this year, so potential energy is automatically gravitational potential energy. So we're looking for GPE. Mass is 50, gravity is always 9.8, and our height is 100. All you need to do is multiply all three of those. So your GPE is 49,000 joules. Any questions on 3 or 4? All right, let's keep going. Number 5. Determine the mass. So we're looking for mass of an object suspended 5 meters above the ground, that's our height, and has 200 joules of potential energy. So that's our potential energy. Again, we're going to use our same formula, gravitational potential energy equals mass times gravity times height. We know our PE was 200. We know we're looking for our mass. Gravity is always 9.8, and height is 5 meters. So 200 is equal to our mass. 9.8 times 5 is equal to 49. Then you're going to divide both sides by 49. So your mass is equal to 4.08 kilograms, which rounded is 4.1. All right, number 6. Determine the height. So we're looking for our height. A 10 kilogram object is suspended, so that's our mass, above the ground if it has 490 joules of potential energy. So we're looking for height this time. We're still going to use that same formula. Gravitational potential energy equals mass times gravity times height. GPE was 490. Mass was 10 kilograms. Gravity is always 9.8. And we're looking for that height. So 490 equals 10 times 9.8, which is 98, times our height. Divide both sides by 98. Your height's going to be 5 meters. Any questions on 5 or 6? All right, let's keep going. Number 7, what is the total mechanical energy? So we're looking for mechanical energy this time. Of an object that has 10,000 joules of potential energy, so that's our PE, and 15,000 joules of kinetic energy, so that's our KE. So the formula for mechanical energy, remember, it's your potential energy plus your kinetic energy, or vice versa, kinetic plus potential. Either way, you're adding them together. That's all that matters. So mechanical energy, your potential is 10,000. Your kinetic is 15,000. So 10,000 plus 15,000. Your mechanical energy equals 25,000 joules. All right, number 8. What is the potential energy? So we're looking for potential energy of an object that has 5,000 joules of kinetic energy, that's kinetic, and a total mechanical energy of 22,500 joules. So that's my mechanical energy. So the same formula, mechanical energy equals potential energy plus kinetic. We know our mechanical energy is 22,500. And that's going to equal our potential energy, which is what we're looking for, plus our kinetic, which is 5,000. All you need to do is the opposite. Since 5,000 is being added, you just need to subtract 5,000. That cancels out over here. So your potential energy is equal to 17,500 joules. Any questions on 7 or 8? All right, let's keep going. So number 9 and number 10 are where the typos started. So if you do the review again today, starting today, I fixed it, everything's great. But if you did it yesterday, then you saw those typos and it might have been a little confusing. It's just worded a little bit differently. So number 9 should have said an object is dropped from an unknown height. It's not dropped from 1,000, it's dropped from an unknown height. But at 1,000 meters above the ground, the object has a kinetic energy of 10,000 joules and a total mechanical energy of 20,000 joules. Now we need to determine the mass of the object. Okay, so an unknown height, but at 1,000 meters, which is our height, the object has a kinetic energy of 10,000 joules and a total mechanical energy of 20,000 joules. We want to know the mass. So on this formula, you're still going to use that same problem. Mechanical energy equals potential energy plus kinetic energy. We know our mechanical energy is 20,000. We don't know our potential energy. And we know our kinetic energy is 10,000. So on this problem, you can go ahead and subtract your mechanical energy from your kinetic. So mine is 10,000. So you're going to have 10,000 equals your potential energy. But remember, you know your formula for potential energy. So we can do 10,000 equals mass times gravity times height, because that's what the formula is. Now you can plug in your height and your gravity, and you can use that to find your mass. So 10,000 equals an unknown mass, which is what we're trying to find, times gravity, 9.8, multiplied by your height, which is 1,000. So 9.8 times 1,000, you have 10,000 equals mass times 9,800. And then you're just going to divide both sides by 9,800. That cancels out on your right. Your mass is equal to 1.02 kilograms, which rounds to 1.0. So any questions on this one?
I kind of got mine different. I think I remember how I did mine. So basically, I had the same setup, but I didn't subtract the 10,000, I think. And then, wait, no, I did. Never mind.
Yeah, a lot of people who got it right did this at the beginning. So then you did it right. Good job. All right. Any other questions? All right, let's go with number 10. Number 10 was also worded a little differently on the review, so I switched that up. This one says a 500 kilogram object is dropped from an unknown height. So again, an unknown height with a mechanical energy of 1,000 joules. Determine the height above the ground when the object's velocity is 1.5. So we know our total mechanical energy. We know the mass. we want to know the height. We're looking for height. And we know the object has a velocity of 1.5 meters per second. So this is another mechanical energy problem. Mechanical energy equals potential energy plus kinetic energy. This time we don't have a potential and we don't have a kinetic. So we're going to have to use the formulas for both. But we do have mechanical energy, which is 1,000. So we're going to have 1,000 equals mass times gravity times height plus 1/2 mass velocity squared. So during conservation of energy, you can take out mass, but this is not a conservation of energy formula. This is a mechanical energy formula. So we don't have kinetic plus potential equals kinetic plus potential. We don't have that. So we can't take out mass. So you do need to leave mass in this problem. So you could plug in your numbers. 1,000 equals our mass of 500 times gravity of 9.8 times the height we're trying to find, plus 1/2 is the same as 0.5 times our mass, again 500, times our velocity squared, which is 1.5 squared. Now again, you can combine 500, 9.8, and all of this right here. So you still have 1,000 equals 500 times 9.8 is 4,900. Still times h, trying to find that h, plus 0.5 times 500 times 1.5 squared. That equals 562.5. Then you can subtract 562.5 because it's being added. Remember, you have to do the opposite. Those are rules of algebra. So that cancels out over here. You're left with 437.5 equals, we still have that 4,900 H. Last thing you need to do is just divide both sides by 4,900. That cancels out on your right. So all you're left with is your height, which equals 0.089 meters, which if you round it, it will equal 0.1. Yeah. Any questions on number 10? That was a lot. Number 10 honestly was a lot. I will post this video later, so if you need to go back and watch it, and you can fast forward to this part just so you can get number 10. Because yeah, it was a lot. All right, let's go over 11 and 12 then. Number 11, what is the kinetic energy? So we're looking for kinetic energy of an object midway down a hill that had an initial potential energy of 1,000 joules at the top of the hill and currently has 500 joules of potential energy midway down. All right, so on this problem, this one is a sort of conservation of energy problem. You just have to look at it that way if you wanted to. You could do it mechanical energy or you can do a conservation of energy. It's totally up to you. I'm going to do conservation of energy, however. So you have your initial potential energy of 1,000, so that's my initial. Then the 500 joules has to be my final. If you're initially at a top of a hill, what is your kinetic energy going to be initially? Zero. Good job. So that means you're just looking for your final kinetic energy. So if you're using the conservation energy formula, GPE plus KE equals GPE plus KE. We said we don't have an initial KE, so I'm going to cross that out. And then I'm just going to plug in the rest of my numbers. My initial GPE was 1,000. My final GPE is 500. And I'm looking for that final kinetic energy. So all you have to do is subtract 500 from both sides. 1,000 minus 500, your kinetic energy is just 500 joules. All right, number 12. A 50 kilogram skateboarder, so that's my mass, has an initial velocity of 4 meters per second. That's my VI. At the bottom of a ramp, so we're at the bottom. What does that tell you about in height?
It is this lowest point is 0.
Good job, 0. So now we want to determine the max height. So we want to look at our final height, which means that would be our initial height. This one's worded wrong too, but it's okay. We can still find it. When you're at the top of the ramp with your max height, what's going to be your final velocity? Max height. What's your final velocity at max height? 0. Good job. So this is another conservation of energy formula. We have our GPE plus KE equals our final gravitational potential energy plus our final kinetic energy. So we said we have 0 initial height. We're going to cross out that initial GPE. And we said we had final velocity of 0. So we're going to cross out that final kinetic energy. So really all we're left with is KE equals GPE. Our formula for KE is 1/2 mv squared. That equals mass times gravity times height. So now this is a conservation of energy problem. We have mass on both sides. Remember what I said we can do when we have mass on both sides? You can just cross that out. You don't really need it to solve this problem, but it only works if you have mass on both sides and if it's a conservation of energy formula. Can't do that all the time. So 1/2 is the same as 0.5. Our initial velocity was 4. Don't forget to square that. Gravity is always 9.8, and we're looking for that height. So 0.5 times 4 squared. That's going to be equal to 8. That still equals 9.8 H. Then you just need to divide both sides by 9.8. That cancels out on your right. So all you're left with is your height, which is equal to 0.816 meters, which rounds to 0.82. Any questions on this one? R11, 11 to 12, any questions? All right, we're almost done. Number 13 was the last typo, sort of. So on this one, we're on a hill that kind of swerves. It's like this. So the ball's rolling down, I'm sorry, the tire's rolling down and then it's rolling back up. So that's kind of what this looks like. So we have a 10 kilogram tire, that's our mass. It rolls down a 1.5 meter incline, that's our height. Then continues to roll up another 1 meter incline. So that's our second height. Final height, 1.5 was our initial height. Determine the velocity at 1 meter. So we're looking for that final velocity. That's what we're trying to find. Does anyone know what our initial velocity is when it rolls down? What's going to be the initial velocity of anything that's going down?
0.
0. Yes, good job. All right, so this is another conservation of energy problem. We have our gravitational potential energy plus our kinetic energy equals final gravitational potential energy plus final kinetic energy. We know our initial velocity was 0, so we can cross out this initial kinetic energy. And then yes, unfortunately, you do have to solve for all three of these. GP is the same as mass times gravity times height. That's going to be equal to mass, gravity, height again, plus our kinetic 1/2 mv squared. Again, since you're working with mass, you can cancel mass in every single problem. Remember, it only works with conservation of energy. So all you're left with is your gravity, 9.8, times your height. Your first height was 1.5. And that's going to equal gravity again, 9.8, times your second height was 1.0. Don't put the same heights. They're different heights. Don't put the same heights. Plus 1/2 is the same as 0.5. You're looking for that v squared. So 9.8 times 1.5, that's the same thing as 14.7. 9.8 times 1, that's still 9.8. And you're adding that to 0.5 v squared, which is what you're solving for. Now you're going to subtract that 9.8 because it's being added. You got to do the opposite. So minus 9.8 from both sides. That's going to give you 4.9 equals 0.5 still v squared. Now, since 0.5 is being multiplied, you got to divide that. So divide 0.5 from both sides. You're going to get 9.8 equals v squared. And then what's the very last thing you need to do?
Root it.
Yep, square root. So your final velocity is going to be 3.13 meters per second, which rounds to 3.1. So that one was a lot too. Again, if you need help, go back to the video, fast forward it to this part, watch these steps. All right, number 14, I lied, had another typo. It says warm air rises, hot air sinks. And that's supposed to be cold. Warm air rises, cold air sinks. That's convection. And that deals with water and gas, any liquids and gases. When the sun heats a concrete driveway during the summer, that's radiation. Remember, that's not touching at all. Nothing's touching. That's radiation. And finally, a metal radiator cap burns your hand when your engine overheats and you try to remove the cap too soon. Well, you're touching it. Anytime you're touching something, that's conduction. So please understand those three. Yes, you are going to need to know them for the test. Any questions on convection, radiation, or conduction? All right, last problem. This talks about thermal energy. Thermal energy, or heat, will always flow from hotter objects to colder objects. It always goes from hot to cold. Always, always, always. Those are just the rules of thermodynamics. The motion of the particles will increase if there's an increase in thermal energy. So if there's more heat, there's more movement. Meaning the hotter something is, the more those particles are going to move back and forth. They're going to shake more because it's hot. C, as a pan of water is boiled on the stove, it begins to evaporate. So evaporate means it's turning to a gas, in case you didn't know that. That steam starting to rise. The entropy of the water molecules will increase. Remember, gas has the most entropy. because those molecules are so spread out, they're moving back and forth constantly. And that's what entropy likes. It likes moving, it likes chaos, it likes disorder. During an ice storm, water on the road begins to freeze. As the water freezes, well, freezing means it's a solid, right? Ice is a solid. What happens to the entropy? Well, it decreases. Solids have the least amount of entropy. And then liquids have about the average. So yes, you are gonna need to know about entropy and how heat moves from hot to cold. Any questions on thermal energy? All right, so I made you another Kahoot game to review. If you want to review this one and the one from yesterday, it's still in that Wednesday folder, you can. Also review this review that we just did right now. If you have any questions, please stay on. One more thing, your grades, they were updated on Tuesday. I did send everyone an email, people who are passing, people who are failing, everyone got the same email. That if you're still, if you're still failing by tomorrow, I'm gonna start emailing and calling home. So make sure you get everything and anything turned in. Don't worry, this test won't go in until next Monday. So you have time for this test, don't worry about that. But everything else that's already in Hack, that's what I'm gonna be calling and emailing about. All right, if you have any questions, stay on. If not, you are free to go.